Alright guys, we're reviewing for our quiz. It is after school, about 5 o'clock, so you may hear some other voices. People may be wandering into my room. I tried to move the microphone away from the fan. I know people were saying the fan was really loud, it was hard to hear. Hopefully this is going to be loud enough. I got the mic turned up as high as I can, stretched as closest to me as I can get it, so hopefully this will really work for you. We're just going to go through basically everything we've talked about since fall break. I'll go through it kind of quick because in theory you already know this. Just a quick review. Quiz tomorrow is not going to be terrible if you know what you're doing. Should not be any surprises whatsoever for you. Okay. First thing we talked about how to use a protractor. All right. So remember using a protractor. Let me get out of here. We said there are two really important parts on this protractor. The center dot is really, really important. That's what's going to get lined up on your vertex. And then the other one's really important is this zero line here. And that's going to get lined up on a ray. Basically on one side of your angle. You got to have those lined up just perfectly. So if I wanted to measure, say, this angle right here, I'm going to take my protractor and I'm going to make sure my center dot hits right at the corner. So I'm lined up right on my corner right there. And I'm going to make sure my zero line, that straight edge, is on the ray. So I'm going to give a little turn, maybe just a little. Kind of hard to do on the board here. Okay, just perfect. Okay, that's about as close as I can get it. Where the ray is lined up on the line, it hits at 0 degrees. Then I'm going to check and see where does this ray cross. If I could trace, it'd be a little bit easier. So I see the green, and I'm looking, okay, well, is it going to be like 130 something, or is it going to be 40 something? And I have to look at the angle and say, oh, hey, it's obtuse. So if it's obtuse, it's definitely not going to be 40 degrees of any kind. So this angle is actually 132 degrees. I see that right there, right where it crosses. Okay, so that's how we use it to measure. We go to draw with the protractor. Right? You start off with a straight line. So you draw a straight line. Use your protractor to make a nice straight edge for me. Don't make any random line you want to. Nice and straight. Right? Then you're going to move your protractor. The dot goes on the end. So see how my center dot on the protractor lines up to the end of the dot, end of the ray. I'm going to take my protractor and rotate it so the zero line hits my ray. And let's say I said to draw 150 degrees. I need to find 150 degrees on my protractor. Problem is there's two of them. So I got to think, okay, well, here's 150 degrees. But if I drew a line to there, I'm going to have an acute angle, and that's not going to work. So I got to go to the other 150, way over here. See right here? Yeah, I know you guys can't draw through your protractor, so use the edge of it. And all you do is you're going to, again, use a nice straight line. Don't make it crooked or anything. Nice straight line. That goes through the dots that you made. And you have now made 180 degree, or 150 degree. Pretty easy. You will be asked to do both of those on the quiz tomorrow. After that, we talked about the names of a bunch of angles. Right? First of all, we had a transversal. Right? And a transversal is just a line that cuts two other lines. It doesn't have to be at any particular angle. They don't have to be parallel. So if I have this two set of lines here, a transversal cuts through it. The transversal is the white line. It just cuts through any two of them. Now what happened here is that made a bunch of angles. I got an angle here, an angle here, and here, and here. All those angles are made. And there are special pairs. There's two pairs that always go together. When I pair, we all those two, hopefully. And we have a bunch of different ones of those. Okay? The first time, okay, that's what happens when I talk all day long and then try to talk again at 6 o'clock at night. Corresponding angles. Right? Corresponding, when I think of corresponding, I simply think of matching. Alright? So if I look at the top right corner up on this set, then down here where the transversal crosses the other line, we'll talk about the other top right corner. those two angles are corresponding. Again, the lines don't have to be parallel. We typically see them when they are, but even if they aren't, they're still corresponding angles. After that, we had alternate interior angles. Alternate meaning on opposite sides of that transversal, and interior meaning in between, in this case the two yellow lines, but in between the two lines. Have to be inside opposite sides. So right here is a pair of alternate interior angles. Opposite sides of the transversal, inside the lines. See if I can do this without the picture getting too crazy. We of course have alternate exterior angles. Same idea, they're on opposite sides of the transversal, but they are outside the line. So marking in green, this top outside angle here. See how it's kind of like on the right side of the white line? So I'm going to look for exterior on the left side, way down here. So marked in green, those are your alternate exterior angles. All right, let's clean this picture up a little bit. We also had, if we had alternate, we of course have same side interior, and we'll have same side exterior. And same side interior angles are exactly what they say they are. Same side, meaning they're on the same side of the transversal, both on the left, both on the right. And they're inside, they're in between those lines. So this pair right here are the same side interior angles. There's another pair over on the other side. This pair of angles, they're also same side interior, but the pair of white ones and the pair of yellow ones are not same side interior with each other, just with the two white and the two yellow. Of course, we have same side exterior angles. Exact same idea, they will be on the outside of the two lines, so they're exterior, but they're on the same side of the transversal. That pair right there. Same side exterior, the pair in green. Okay. We also had a couple other kinds. There are ones we've actually talked about before. We had adjacent angles. There are lots of adjacent angles in this picture. But the key to adjacent angles is they have to be touching on a side, like they have to share a side and a vertex. So here's a vertex, and I need a pair of angles who have the same side. This angle here, this angle right there. They share the vertex and the side in between. Those are adjacent angles. You can have adjacent angles that are next to each other like this. Those two are also adjacent. Not normally a set we see together, not kind of sideways like that, but they're still adjacent. Last type was vertical angles. This vertical is not like vertical up and down. A lot of people actually call these opposite angles. And I'll often refer to them as diagonal, right? The idea is they share a vertex, so they share a corner. They're across from each other as long as they're made with two lines that cross through each other. So this is a pair of vertical angles. They're across from each other. Those kind of look up and down, all right? But we could also have this pair. So another pair of vertical angles, all right? So these have to be kind of diagonal or across from each other. The vertical angles and the adjacent angles are the only ones in all of this that are not dependent on having a transversal. I could still have vertical angles or adjacent angles without a transversal in the picture at all. We do see them when a transversal is there, so that's why they're included in this section. Once we knew all of what those angles were, we took some time, we did all those posters, we basically came up with all these theorems on our own. First of all, you do need to know the difference between a theorem and a postulate. Postulate, we talked about this word a long time ago, it is an accepted rule. Right? It's one of those things where it just is. Don't ask why, don't ask how did anybody know that. We all just go with it. Mathematicians do the same thing. We have postulates in math all the time. We just accept them. We're like, oh, okay, that's true. Who cares why? It just is. A theorem. A theorem is something that must be proven before we accept it. Right? And the idea is we kind of proved our theorems already with your posters that you guys did. They did something called proof by example. You came up with a couple examples for it, a couple examples against it, and we're taking that as our proof. We will eventually, guys, do the proofs with these. We'll probably do 2-column proofs and something called flowchart proofs. My projector just went out, so I'm going to have to start typing stuff for you. But we will eventually do, like, formal proofs. But for now, we're going with, you know what? We've proven these. We kind of proved them. We used an example, and we did it. All right. I know, guys, I'm sorry, this is going to have to go on a white background because of the way it types. It's going to be kind of annoying. All right, so we have a bunch of postulates and theorems now dealing with those special angle pairs. We have the corresponding angles postulate. This one we simply accept. We just believe it to be true. We don't ask questions. We're just like, you know what? Corresponding angles are congruent. They just are. We just go with it. I'm going to make this font a little bigger. My guess is it's kind of hard to see. But isn't it so much neater than me like writing things out? Don't answer that. My handwriting's beautiful. We all know that. We have alternate interior angles theorem. Okay, it'd help if I could type. Remember, a theorem, the idea is we have to prove it. We have to show that it's true. We can't just accept it. We had several groups do this poster throughout the day, and they showed us a bunch of examples. And it simply says that AIA are congruent. The other theorems are very, very similar. The alternate exterior angles theorem says that alternate exterior angles are congruent. The vertical angles theorem also says that vertical angles are congruent. All right, now we're going to get to the same side interior ones. Let's make this font bigger so y'all can see it. Silly box in the way. There we go. All right. Same side interior angles theorem. This one simply says that same side interior angles are, do you remember? Yes, supplementary. And I hope you said that out loud, and I hope your brother or sister or niece or nephew is looking at you funny. Yes, they're supplementary. Absolutely. What does supplementary mean again? Yes, they add up to 180. Whenever I ask you what supplementary means, don't simply say 180. Supplementary does not mean something by itself is 180. It means two things add to 180. Two angles add to 180. You can't use it as if it's just one thing. You have to emphasize that there are two things that add up to 180. Similarly, in the same way, same side exterior angles theorem says that the same side exterior angles are supplementary. Now, I've managed to miss one very, very, very important part in all of these. What am I missing, right? We've talked about all these theorems, but what am I missing? I'm missing something very, 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 very important. You got it yet? I hope so, because I'm about to type it. Every single one of these should start off with if two lines are parallel and are cut by a transversal, then these things are true, right? The key is parallel. All of these are not true if the lines are not parallel, and you guys all found that on your posters. I made you all draw a pair of lines. Ooh, I'm really messing up the font on this. I made you draw a set of non-parallel lines and said, is this still true? The only one that does not go with, see I'm skipping it, is vertical angles. Why is it not true with vertical angles? Do you remember? Maybe. Okay. The idea is that vertical angles don't have to have that transversal. They don't have to have the parallel lines with them. Remember, we said vertical angles could be by themselves. So the if part of this theorem is simply if two angles are vertical, then they are congruent. Okay. So if I wanted to put this in if-then form, that's all it is. The idea is vertical angles, again, they don't have to have the parallel lines with them. They could be just an X, right? They would look just like that. There's parallel, or there's vertical angles there, but they did not have to have parallel lines. Every other type of angle on here has to have a set of parallel lines. Alright, so if you need a moment, there are your entire list of theorems that we have. You do need to know these very well. After the quiz on Thursday, we'll either start then or on Friday, our next section, which is actually using the converse of these. So you have to know the if-then form, because if you don't know if-then, you can't write the converse statements. And hey, look at that, bringing back stuff from before. Who knew? Alright, so the other things we did, not a whole lot more, but we did some solving with these. And let me actually bring up... No, never mind. I don't have my software downloaded for today. Alright. So, we said, okay, so we got a set of parallel lines and a transversal. And we said, okay, well now what if we had some algebraic expressions for some angle measures? You know what? No, we're not even going to get that complicated first. What if I know the measure of an angle? Let's say I know this angle right here is 56 degrees. What would this angle right here be? So I'm looking for that question mark angle. So the first thing I think to myself, what kind of angles are these? Hopefully I've thought to myself, oh hey, they're same side interior. If they're same side interior, I go back to my list, down to same side interior. Hey, same side interior angles are supplementary if the lines are parallel. So in this case, these lines are parallel. So supplementary, remember, means they add up to 180. So since I already know the number, I can just take 180 minus 56, and that's going to give me the answer to the angle. Anybody know that off the top of your head? Doing the math on the paper, hopefully not grabbing a calculator. I'll give you a moment. Should be 124 degrees. So somewhere on your paper, you would either write 124 by that angle. You would circle your answer real big, make sure I know what's what. Okay? Alright, but what if, instead of giving you numbers, I gave you an algebraic expression for some of these angles? Let's say I know this angle is 4x plus 7, and I know this angle is 3x minus 5. And I said, solve for x. Okay, again, you have to think, what kind of angles are these? I'm hoping we all know those angles are alternate exterior. And again, I think to myself, are alternate exterior, are they supplementary or are they equal? And I look and I say, hey, wait, I know alternate exterior angles without even looking at my list, they're equal. So I'm going to set up an algebraic expression, 4x plus 7 equals 3x minus 5. Alright? The idea is if they're congruent and their measures are equal. Once I have that set up, I would do the algebra, solve through it. Guys, again, on your quiz, you probably won't get any decimals, but negatives are perfectly fine to have. What if I added, find the angle measure? What would we have to do? Well, we're going to have to solve for x first, right? Alright, so if I have this, I'm going to go ahead and subtract 3x from both sides. As best as I can do this by typing and not writing. We end up with x plus 7 equals negative 5. I'm then going to subtract 7 from both sides. Get those to cancel. I'm left with x equals negative 12. Exactly. Just so you guys know, I did make this problem off the top of my head. I don't think it's going to look very good. But the idea is, we take this x equals negative 12, and we're going to plug it in to one of those algebraic expressions. So I'm going to do 4 times negative 12 plus 7. Okay? I would do that in my calculator, and that's going to give me the degree measure, 95 degrees, 110 degrees. Like I said, I made this one up off the top of my head about 10 seconds ago, and we end up with a negative degree measure. You're not going to have that on the quiz. I do those ahead of time, you'll be fine. Alright? But that's the idea. You solve for x, and then you plug back in. Okay? The last kind of problem we had, and we worked on that today, was that we looked at some really kind of complicated problems. And the only issue with the complicated problems is not that you don't know how to do it, but that it's hard to know what to do and how to get through it. Okay? So, let's look at one, and then we'll be done with your review. How long have I made you listen already? Ooh, 20 minutes. Look at you, surviving to the end of the video. Alright, so here's a picture. This is kind of similar to one we've already done. Okay? And we've got an angle that is 5x plus 6. That's going to be this angle in between there. We have 8x plus 7, which is going to be this measure in the corner right there. And 16x minus 8, which will be over in this corner right there. Alright? And I want you to solve for x. Alright, so let me fix up this picture here a little bit for you. Make it a little bit bigger so we can see some of it. Alright, we're going to solve for x. Alright, there are a bunch of ways to go about doing this. Alright? Alright, so we're going to do it this way. And this is, if you watch the other videos, or this one we did in class, it's probably slightly different than what we did before, but I'm going to show you anyway, because I think this way might be a little easier than the way I did it in the video. I see this angle right here. Ooh, that's really big ink. Let's try this again. Let's use this marker. I see, there we go, this angle right there. And I see this angle down here. I like those two angles, looking at those together, because they're along the same transversal. Alright? So I gotta think to myself, what kind of angles are those? And I hope you see, I know it's kind of hard with that really big line on top of it, those are actually same side exterior angles. Alright? I'm going to call this angle 1 over here. So, this tells me that angle 1 up here plus this one down here add up to 180. Alright? But if they add up to 180, then I can subtract one from 180 and get the other. So, the measure of angle 1 is actually equal to 180 minus the 16x minus 8. Alright? Because they are same side exterior, supplementary, which means they add to 180, which also means I can take 180 minus one of them to get the other one. Alright? Then I'm also going to look. I see this angle here that we already know, and I see this angle up here. Alright? What kind of angles are those? They're along the same transversal, right? There's their transversal. Does the colors help a little bit pick them out? Yeah, they're corresponding. Corresponding means they're the same thing. Alright? So that means this other angle up here is also 8x minus 7. And yes, I make sound effects, and you get to hear them on the video. Gotta keep you entertained somehow. Alright, so I now have 3 angles up top. What do you notice about these 3 angles? Do you notice anything? I hope you do. They make a line. Yay, lines. What's the degree measure on a line? Yeah, 180. Alright, so we end up with, let's make sure I've done this right, yep. We're going to take angle 1, which was 180 degrees minus 16x, wait, I missed my parentheses, minus 16x minus 8, plus the 5x plus 6 there in the middle, plus the 8x plus 7, that all equals 180 degrees. because they make a line. All right, let me go ahead and color code that for you. And working on the colors. Here we go. All right, the 8x plus 7, that was our blue angle. And the 180 minus 16x minus 8 was the red angle. The 5x plus 6 was the one that was already there. That's our equation that we end up with. It looks kind of ugly, but there's just a lot of combining like terms and we'll be okay. Alright, so the idea with this one was, I recognized there were two transversals. We had the one that's in blue and this one here in red. So I used what we knew, the three angles in black, and put them all in a line together based on their transversals. Alright, once I have that, now I need to combine like terms and solve. So I'm going to work with this red part here real quick. The negative needs to distribute, right? So it's negative 16x plus an 8. So I end up with 188, right? Because 180 plus 8 minus 16x. So I got rid of those parentheses. Plus 5x plus 6 plus 8x plus 7 equals 180. Make this font a little bigger. We'll get through this problem, guys, and then you are done listening to your review. Alright, so I see lots of like terms on the left I need to combine. Alright, I've got 188 and a 6 and a 7. So altogether, what would that make? Anybody know? Okay, well the 188 plus the 6, and we're going to do this without a calculator, gives us 194, plus the 7 is going to give us 201. Then we got to look at our x's, and I see a negative 16x, a 5x, 5x, and an 8x. So fun with negatives tells us that that's going to be, anybody? Hope you're talking out loud to yourself again. Minus 3x. That's still equal to 180. We add the 201, or sorry, subtract the 201 from both sides. Negative 3x is equal to negative 21. Divide by negative 3. X ends up equaling a nice pretty 7. All of that and a nice 7. Alright? You will have one of these complicated problems. I know they're tough, I know they're hard, I know they're long, and you don't know what to do with them, and complain. You'll have one of them on the quiz. The rest of the quiz you'll be fine with. Good luck!